A new day, a new project, and Santa came earlier this year. The nice people of Kaiweets sent me a really nice smart meter. There we are. Ta-da! You know, guys, my panels are running big time. Another two down there, bright new, and up there another one. I think I made it like 4 years ago or something. It's running great. So, you know, look at these cables here. All right, a lot of cables, a lot of connections, and I was thinking about having what? This guy, a clamp meter from Kaiweets. That's HT208D. It's not only a clamp meter, but it's also a multifunction multimeter. What we got here, AC/DC, oh no, it's not the band, alternating current and continue current, of course, and direct current. Clamp meter, well, it's pretty heavy. It's more than half kilo here. Oh, and look here, look at the punch. Look at this case, like always, beautiful case. Okay, good grip here. Good spring too. We have the batteries. This is a really clever idea. 330 grams with the batteries. This machine is measuring in true RMS. What means RMS? It's root mean square. And for alternating electric current, RMS, it's equal to the value of the constant direct current that would produce the same power dissipation in a resistive load. This is very important because, let's say, if we have a duty cycle to measure, if we have some, let's say, a square wave to measure, the true RMS gives you exactly the right amount of power measurement. So this is the real measurement of the energy in that circuit. Okay, so let's look at some functions of the meter. First of all, this multimeter have a 6,000 counters. DC volts from 600 millivolts to 600 volts. In DC, we have a plus minus 0.5%. Okay, then 1000 volts, the resolution is 1 volt, and the tolerance is 0.8%. AC, of course, from 0 to 750, and we also have this VFD. And VFD, it's a very interesting function. When we are measuring AC currents and voltages, there is a low pass filter. So it's cutting the interferences or the harmonics and all the other signals mess with the measurements. Then, of course, DC amps, AC amps. Another nice function is the Inrush Current. So this clamp meter, it's able to measure those very short peak currents. You know, like a big motor, you know, in the moment when you plug it in for a split of a second, there is a huge amount of current. This one can measure that. So that means it's very fast measuring that. And also we have resistance meter from 0 to 60 mega ohms, 1% tolerance. Capacitance from 0 to 1000 microfarads and 10 millifarads. So it's pretty okay. 100 millifarads to 0.1 with a tolerance of 4%. Okay, that's pretty okay. Frequency up to 1000 kilohertz. Interesting. And also from 10 megahertz. Okay, up to 10 megahertz. This is great. Okay, we'll see about that. Also, it can measure the duty cycle. This is very interesting and very useful when you are working with pulse width modulation devices. Temperature up to 1000 degrees Celsius or 1032 degrees Fahrenheit, and that's it. Okay, now let's look at the instrument itself. The first two steps here are for clamp meter, for measuring the current. Next one, it's voltage with the FFD on. Through RMS, we can choose alternate current or DC current through this function switch. Now it's on auto, AC and DC. So AC without low pass filter, AC with the filter, and DC. And also what's nice about AC, in the same time it shows the frequency. Okay, let's go to the next step here. Frequency meter and duty cycle meter 2. And here we have 4 functions. First is Ohmmeter, resistance meter. Then we have the continuity meter or the beep meter, let's call it. Next one, it's diode mode for measuring semiconductors. And the last, it's capacitance. Okay, then we have thermometer here. We have to apply that sound, and we have in Celsius and Fahrenheit up there. The next one, it's low Z voltage meter. What means low Z meter? Oh, this is very interesting. You know, when you are measuring a voltage, usually or normal, let's say, we need the voltmeter to have a as high impedance as possible. Let's say we have a resistor here in a circuit, you know, in between. This resistor, let's say it's 1 mega ohm. If we want to measure the voltage here, we don't want to interfere in the circuit. So we don't want to apply an extra resistor, you know, to have a wrong voltage measurement. So that's why this instrument have a high impedance. When we have the low impedance voltage meter, let's say we have the same schematic on mega ohm, all right? We apply the voltmeter here, but in the same time we apply a resistor too, and finally here we have the voltage. So somehow there is a load into the circuit. Sometimes we need a little load to be sure about a capacitor or voltage on a capacitor, if the circuit is okay and stuff like that. I never encountered this kind of function to any other meter before. And as long as we are here, let's see the difference in impedance or internal resistance, let's call it, between these two functions. And here I have KM601 from Kaiweets 2. And let's go to DC voltage in high impedance. Okay, there we go. So here we have 14 mega ohms, 18 even. And if we go to low Z voltage meter in DC mode, we have 292 kilo ohms, 300 kilo ohms. So that means our additional resistance here is 300 kilo ohms. In our situation here, the impedance is more than 15 mega ohms. You don't even feel it. It's like a phantom measurement inside the circuit. Very interesting function. For now, there are few interesting things about this meter. First of all, we have that low pass filter VFD for measuring voltages in AC, alternating current, and also we have this low Z voltage measurement. And the last here, it's live voltage. So of course it showed me voltage because we have a lot of wires around here. The voltage sensor, it's up here, the top. I am the ground in this situation, you know. I am the ground connection. So that's why it's beeping as soon as I touch the meter. You see? So there we have the wire to the lamp. I'm trying to avoid being a ground connector. You see, we can go like this maybe. It's very, very sensible. You know, you can see the wires into the wall. Look, that's the wire going down to one of my mains there. And we'll see about current in a bit going outside to my solar panel install on batteries. And now let's have some tests about measuring voltages and some other stuffs. Okay, we can try to measure the main voltage. Here I have the mains. Let me take this out. Be real careful about that. So we are on voltmeter and let's have it on AC. Okay? Let's see. $241 volts, 49.9 hertz. So this is my main voltage. Be really careful when you are doing these tests because it's high voltage there and it's very dangerous. And now let's go to DC and let me measure what? Okay, here we should have a battery here. All right, let's see how many volts. 8.10 volts. Absolutely yes. There are 2 elements of lithium battery. 8 point. Oh yeah, they are pretty charged. Very nice. Okay, now let's go to frequency meter. And I'm gonna use this little guy. Function generator. Let's go to hertz. 441 hertz. Okay. There we go. And it's perfect. 441.98 with 50% duty cycle. 443. Perfect. Let's go further. 1000 hertz, 250, 5000, 10,000 kilohertz, 25 kilohertz, 50 kilohertz, 100 kilohertz. Oh, don't give up on me. Oh, doesn't see 100,000 hertz. It's so funny. It can see 100,000, but it can read 153. Look there. 250, of course. 500, of course. 1 megahertz. No, but it reads 2 megahertz. Okay, so it's something to do with 100 kilohertz, 1 megahertz, something like this. So it's a matter of the internal counting or something. That's funny. Oh, this is a very low frequency. It's 1000 millihertz. 10 hertz, of course, reading 50, no problem. Well, I'm really happy with this guy. So it can read 2 megahertz without problem. Let's go back now and let's have pulse width modulation. Now I should have an idea of the duty cycle. You see, I have a 10% up here and it's reading 89.6. If I go to 50% duty cycle, it gives me 50%, 49.6. 80% and I got here 20. Okay, we should have an oscilloscope to see the way it's working, but anyway, it's a perfect concordance here between numbers. That was for frequency meter and duty cycle. Alright, now let's go to the other functions here. Ohmmeter. Let me have some resistors. That should be 82 ohm, 7.8. Do I have some others? Okay, let me see these guys. Here, this should be like, let's say, 39 kilo ohms. Nothing? Oh, we are in continuity mode. Sorry. Okay, now, ohmmeter. 38. Okay, let me have this guy measuring this resistor too. I really trust this little. 38.79. Let's see. Our friend here. 38.72. 73. Very close. Very, very close. What about key M601? $38.76. Perfect, like this guy. But let's remember this is mainly made for current. I don't expect too much. And now let's have a capacitor, one of these guys. 109 picofarads. Do you think it's measuring picofarads? I don't know. Let's put diode and, oh yes, 110, 0.1. with a little tolerance. Of course, let me see KM01 on capacitance mode. And this one is saying 0.78 nanofarads. I think this is better. Let's try another one. This one should be 0.047. So 47 nanofarads. Okay. This one gives me 56 nanofarads. KM601, 59.95. And our new friend here, 57.27. So it's pretty close. Well, I don't know. Because I don't have some calibrated capacitors good enough to say that that's the value and nothing else. 66, and this should be 68. 66.52. Okay, very close. And what about KM? 67.3. They are very close. That's good enough. Now, this is continuity mode, so very easy to understand. We have a piece of wire, and also this green one, it's blinking when we have continuity. And the next one, it's diode mode. Do I have a transistor here? Oh, I have a diode. 715. And the other way, this is a very clear, good working transistor, diode. And this is that should be a transistor or something. Let's see. Okay, that's the base there. I think it's an NPN transistor. Okay, base and emitter. Yeah, right. Emitter, collector, no. Yeah, it's an NPN transistor. Okay, let's have this temperature sensor working. Evidently, there is a temperature sensor inside the machine. Now it's saying 27 degrees. Yes, it's possible because I keep it in my hand and obviously got some temperature from around 26 degrees and growing. 31, 32. Let's measure this 200 and 400 and something. Okay. Oh, it's blowing. It's burning. Let me have my soldering iron. Fixed at 350, I recall. Let's see. Coming up to, okay. Yeah, 350 around. 347 on my display. 347 there on the machine. Yes, it's very accurate. 412 and then going down and up again. Yes, because the thermostat is doing the job. And down and up. Yeah, pretty close. Maybe 10 degrees. Nice. I never test that. But it's very clear. It's working. Okay, so that's it about measurements, voltages and all these stuffs. Now we need to measure some currents. What else to say? This one turns off in 15 minutes. This one turns off in 15 minutes. If we want to have that function auto power off, we have to press function for more than 2 seconds. And that should turn off the function. Here we have the lighter. You see? Okay, this one we have to turn it off. And here we have the lighter too. Everything is auto ranging. You don't have to take care about what else. Also, when we keep this down, the hatch button here, we can have a instant memory of the latest measurement. It's a hold function. Okay. And also something interesting here. In DC current measurement mode, this key, this one here, turns the clamp meter to 0. That means it allows the user to set the magnetization effect to 0 when measuring DC. This magnetization effect in here. Okay, that's very interesting. So it's a kind of calibration, zero calibration, let's call it. And that's only for DC current measurement. In all the other measurements, this button here have a relative mode. Auto or relative. Okay. Well, I think it's pretty straight to understand how this meter is working. Let's measure some current. Well, okay, we still have some sunshine here. It's in the afternoon, so it's pretty low. And let's have a try. Auto, 0. Let's go on auto and let's have a clamp meter measurement. 40. We are on DC. Almost nothing. Why? My inverter is working, but probably there is no consumption. But let's see this one. So we have 2.20 jumping up and down because the inverter is supplying according to the current in the house. 3.65. Yes. And let's have the general. And we have 5.86 amps going down to the inverter. But this is really funny. So these are somehow you see these guys here, they are very close to the main junction. So we have a 3.3 amps running from these panels. Then I got these panels here, and these are supplying only 30 milliamps, 300 in fact, half of amp. What about this one? Yes, same. What about these guys? Okay, because it's shadow anyway, but the most power is supplied by those two panels at the end of the row. We got an amp here, and we got a 2.4 here. Like I said before, there are in the shadows these two guys in the middle. So the single ones who are pretty high are these two. So it's normal to have a bigger current there. So my inverter now, it's delivering 214 watts. Let's have a little bit more power in. Request, but I'm afraid I can't ask for more because there is no sunshine on the panels. But I can check this current input to the inverter, and I have a very clear almost 7 amps in. This is great. What about, okay, that's the other install. So now it's charging with 2.1 amps, and I have 850 milliamps from the other panels. This is an MPPT transforming the current from the panel to 12 volts. And here I have a power supply, which helps me sometime when it's not enough power for the second install of mine. And we are running like 175, 167 amps straight to the batteries. Yes guys, so I'm really satisfied about this multimeter, smart multimeter from Kaiweets. So I've been really searching for a reliable clamp meter for my solar install and for my solar project. I'll do a test soon with a proper calibrated resistor to a certain voltage and so on, and we can find exactly the amps, the current rushing into the circuit. If you have anything like solar chargers, MPPT chargers, solar arrays, panels, cables and stuff like this, a clamp meter is really necessary because it can show you the current through the wires. And also if you have a power grid tied or off-grid inverter, also you can measure the output in alternating current, 120 or 230 volts, doesn't matter. And you can have a really idea about the current running through the wires. Okay, finally, great tool. It feels good, it feels solid, it feels steady. For this price, having a almost complete multimeter with voltage and all the other stuffs, I think it's a bargain. You're gonna have a link with a discount to purchase this from Kaiweets, and like a Kaiweets user, I can say these machines never gave up. They never let me down. They are solid and they are reliable. I really recommend you. At least this one, full range for solar installs, batteries and any other kind of DC, AC currents, big currents, tens or hundreds of amps. Okay, that's it for today. I hope it's useful. Don't forget to have a link down there. If you want to purchase this, you have a discount. Just apply the link. And see you soon with some other news. Thank you for now. Please like, subscribe, and don't forget, have fun.